Okay, do you see here the this OneNote screen?
Yes.
Okay, this is the example 3.9 we were doing yesterday. And then there was a time for the quiz, I think. So we had to stop here. Now when we multiply by row, 2 to 5, we get 1 plus row sine phi d rho d phi. Here limits are constants, we can separate them. When we do integration with respect to rho, we get rho plus rho square over 2, and the limit is from 2 to 5. Then integral of sine is a negative cosine, and the limit is from pi over 6 up to pi over 3. This is 5 plus 25 over 2 minus 2 minus 2 to 4, 4 over 2 is 2. Cosine pi over 3, cosine 60, 1 over 2 minus plus cosine 30, square root 3 over 2. And when we do this, we have 5 minus 4, 1, 2 plus, so it is 27 over 2, and then 2 mushtarik from in the denominator in the other part, so it is 4. And then we have negative 1 plus square root 3. So this is the final answer. And if we compute this using calculator, that is 4.941. So this is the solved example. Now let me do some questions from exercise. Exercise of this chapter 3. There are some, the book called it not exercise, but it called it problems. So we call it, let's say, 3 exercise chapter 3. If you have noticed, that is good. If not, I have uploaded yesterday, I think yesterday or day before yesterday, we were talking about the book, this chapter 2 and 3, and we also have to do chapter 4, some part of chapter 4. And someone asked me about the answers. So yesterday I could find this book. I have deleted chapter 2, chapter 3 from the Google Drive and uploaded this book. And now, instead of those chapter 2 and chapter 3, you can delete them and download this book, this whole book, which is available, this whole book. So you can download it. All right. And use this book. And at the end of this book, you can find the answers. Okay. Now, let me share, instead of this only one note, let me share this whole thing. So, do you see this book now? Hello?
I searched, doctor, but I don't find it.
Do you see the book on screen?
Do you hear me? Do you hear me, doctor?
Yeah, your voice is very low. So, is there anyone listening me in the class?
Yes, we can see it.
Yes,
Yes. So, I just want to make sure that you are seeing what I'm trying to show you. Okay, here, question number 1, 3.1, 3.2, 3.3, 3.1 and 2. 1 is about DL, 2 is about DS, surface area, 3 is about DV. So, the question number 3, for example, using the differential length, find the DL and the length. Using the differential length DL, find the length of each of the following curve ABC. Which one you want me to show you the solution? 3.1. Okay, so let me just copy and paste this whole 3.1 here, and then let us do one of this solution. So which one? No one is saying anything.
C.
doctor, do you hear me?
Okay. Yeah, I can hear you, but your voice is very, very low. In C, we need to have DL. We need to find this DL. DL, okay? Just this DL. And here R is equal to 4. Theta is between phi 30 and 90, and phi is a constant. Of course, R equal to 4 is also a constant. R equal to 4 is a constant. And the phi is also constant. Only one thing is not changing, and that is what? Theta. And what are the coordinates? Or let me ask, what is the coordinate system for part C? It is spherical. It is spherical. Part B, spherical. Part A, cylindrical. Okay. In part C, when R is 4, constant dr will be 0. When phi is constant, d phi is 0. So what we left in dl, let us say over L, is only d phi, and that dl is r d theta in the theta part of dl in spherical coordinates. And then what is integrand here? 1, because they are saying find the length. So integrand is 1. And what is a theta? 30 to 90, yani pi over 6 up to pi over 2. And here r is not variable, r is constant, which is equal to 4. Integral of 1 with respect to theta is theta. Then from pi over 6 up to pi over 2. So it is 4 bracket pi over 2 minus pi over 6. So it is 4 pi over 3. 4 pi over 3. Okay. And when we do this by calculator, what is the 4 pi over 3 equal to? We can get this answer in in decimal places. This is answer in fraction quotient. So this is question number 1, part C. And how much is this in decimal? It is 4 multiply pi divide by 3, and that is equal to 4.1888. Continue like this. So we can write it as 4.1889 and stop here. Okay. Now you are seeing calculate the area. Now this is question number 2 with the ds. So here we need to find area. Now here I did part C. So let me again ask you guys. We have here part A in cylindrical, part B in cylindrical, part C in spherical, part D in spherical. So which one of these part A, B, C, D should I do for you? And you do the remaining. Yes, Shabab?
D, doctor.
D. So here for part D, you need to look at which is constant. R is changing, theta is changing, so phi is a constant. And when we look this cylindrical coordinates, when phi is constant, it means d phi is 0. So ds for this will be with dr and d theta. Dr and d theta. Because phi is a constant, so d phi is 0. So where is the d phi? That part of ds will be 0. So the only part we will use is the one with the dr and d theta, and that is r dr d theta. Actually, this has the unit vector. If we put here a phi, the unit vector, we should put here arrow. So this is with arrow vector notation, and we do not put this arrow, so this is just area element. And then the integral we are going to solve for this problem is so what should we call it? Area. Okay. Integral over S ds, and this will give us double integral. Integrand is 1, so just r dr d theta is left because we are finding the surface area. Integrand is 1. R is going from 0 up to 4, and theta is going from pi over 3 up to pi over 2. Integral with respect to r is r power 2 over 2 from 0 to 4. Multiply integral with respect to theta is a theta, and from pi over 3, 60 degree, pi over 2. So we will get 16 over 2 is 8 minus 0. So it is 8. Then pi over 2 minus pi over 3 is pi over 6. 90 minus 60 is 30. 30 is pi over 6. So again, it is 4 pi over 3 by chance. And that is 4.1889. So this is just by chance. 4 point. Okay. So here is part D of this question. If anything is not clear, I am waiting here for you before I go to
Doctor,
the, yes.
you mean 4.1888?
This 8 will continue indefinite. So we stop and then put 9.
Okay.
Okay. So this is the next one. And here now you see one with the differential dV to find volume. Let me just put it here. And this question is about volume. Here again we have A, B, C part. Let me show you one of them. So let me do here part B. Part B is cylindrical coordinates. In cylindrical coordinates, dV, volume element, is rho, d rho, d phi, dz. You will have a formula sheet with you which give you what is dV in cylindrical coordinates. What is dV in cylindrical coordinates? You can see this in the formula sheet which I will give you. Okay, then volume is equal to, so let me write the full word, triple integral rho d rho d phi dz. Integrand is 1. When integrand is 1, the answer from this integral will be volume of the solid, in which rho is going from 2 up to 5. Phi is going from pi over 3 to pi, and z is going from -1 up to 4. When all the limits are constant and integrand here is the product of these different variables, we can separate it. Integral with respect to rho is rho power 2 over 2, and limit is from 2 to 5. Integrand with respect to phi, there is no phi, so there is 1. Integrand is 1. Integral of 1 is phi, and phi is from pi over 3 up to pi. Multiply, there is no z, so integrand with respect to z, we consider 1 as here integrand, and then with respect to z is z, and z is from -1 up to 4. And now you simplify. 25 over 2 minus 4 over 2 is 2. Now we put bracket, pi minus pi over 3. We put z equal to 4 minus -1 plus. And 25 minus 2 to 4. 21 over 2 multiply 5. 21 multiply 5 is 5. 5 to 10. 105 over 2, and then pi minus 3 pi minus pi, 2 pi over 3. So you can write it as 210 pi whole over 6. And you can use calculator if you want to get answer in decimal places. Again, if anything is not clear. So these are very easy, very trivial questions. You can see we didn't face any kind of difficulty. Now, next questions are when we need to do this surface integral, not surface area. So far we did what? Length, surface area, volume. Now we will do surface integral, volume integral this time. So you are seeing here now question number 3.4, 3.5, 3.6. So let me do 3. How many or which one should I do? Okay, let me do 3.4 maybe. Okay, here given that rho s is equal to x square plus y square. X square plus xy rho s over ds, where the region is y equal to x square and x is from 0 to 1. From 0 to 1. So this is a parabola. This is a parabola. And in this parabola, x is going from 0 to 1. So let us say this is 1. So when x is 1, y is 1. So we have this, and then x is from 0 to 1. So we have this line. And y is less than equal to x square. So we have this part. Okay. Is this figure clear, Shabab? If not to anyone, he can ask me. If this figure is not clear to anyone, he can ask me.
Doctor, we take all of the area.
So this is 0. Here is 1. This is
Doctor?
x-axis. This is y-axis. So this over this area we are integrating. Over this area we are integrating. And rho. This rho is not like the rho we have before. This rho is a name of some function, like f of xy. You are asking something, Shabab?
Yes, doctor. Do you hear me?
Yes.
The area under the curve is the whole or just that you... okay.
This is whole area.
Okay.
We are taking the value of x, value of y to integrate this function from this area. And then we need to integrate over s, rho s capital ds. Now this is equal to rho s is x square plus xy. Now ds, this is in xy coordinate system, and in xy coordinate system the area element is dx dy. Now, after this, look here very carefully, Shabab. If you write dx first, then make a line parallel to x-axis. Then look what is x equal to on the left hand side and what is x equal to on the right hand side. Now when we look x equal to on the left hand side, we see that x is equal to square root of y. This line is x equal to 1 and this line is y equal to x square. So this choice dx dy is not good because we need to do with the square root. So I choose here dy dx, dy dx, and when you do dy dx, then you make a line parallel to y-axis, looking at this one. And then look what is y at the bottom, it is 0. And what is y at the top? It is x square dy. Now let me use just black color for this solution and write it again. So y at the bottom is 0, y at the top is x square. So we are not dealing with square root. And then x, in this whole region, x is going from 0 and up to 1. So this is how you will set up the limits. This is same like Math 201 you have done before. Now integrate with respect to y, 0 to 1. Now we cannot separate because limits are variable. So integral with respect to y will be x square y plus x y power 2 over 2, limit from 0 to x square and dx. 0 to 1, y equal to x square, so this will give us x power 4 plus y is equal to x square, so y square is x power 4, so it is x power 5 over 2, and lower limit will give you 0 dx. So this is equal to x power 5 over 5 plus x power 6 over 6 times 2, 12 from 0 to 1. And when we apply limit 0, 1, we get 1 over 5 plus 1 over 12. And 60, here is 12, here is 5. So 17 over 60 is the answer for this part. Any question in making the figure, in setting up the limits? And this is nothing more than Math 201. Okay, so no one is asking any question. Let me go to next. 3.5 is,
Doctor,
yes.
I can't see the book in Google Drive.
So maybe it is synchronizing, but it is over there. Maybe in your computer it is, or in my computer it is synchronizing, but I have uploaded the book and okay, in Google Drive, let me check. Answers and book, elements of electromagnetic, book solution, elements of electromagnetic. Yeah, it is there. Oh, no. In your shared elements of electromagnetics by Matthew, I am seeing in my Google Drive. So maybe it will just take a little more time to.
I can't see it also.
You can see?
I can't.
Cannot.
Yeah, cannot.
Okay, just give me 1 minute. Folder Google Drive. So this is Google Drive. Okay, now I'm uploading directly electromagnetics, elements of electromagnetics.
Also, the recording for the yesterday is not there.
It is there now. It should be there now.
Okay.
Sometime it take a little time to synchronize. Okay, in math, in this folder, now I am putting this file book, elements of electromagnetics. It is coming there in the shared folder. Just give me a few seconds. In the shared online Math 302-S203, do you see this book now?
Yes,
Book.
Doctor. It's there.
So now it is there?
Yes.
Okay, that's good. So you can, if you want, you can open that book. Now, here you are seeing the book on your screen. 3.5 is h equal to this. And we need to find h dot dl, where L is along the curve y equal to x square and x is from 0 to 1. So let me do this for you. Okay. Now again here y is equal to x square, and here we are not solving surface integral. We are solving line integral. With this is h and L. This is in Cartesian coordinates. In Cartesian coordinates, dl is equal to dx ax plus dy ay. Ax and ay are unit vectors. And the integral h dot dl, this h is a vector, so dl should be a vector over line L. H is x square ax and dx ax, so it is x square dx ax dot ax is 1 plus y square dy over L. Now our next job is to convert everything into one variable. So first one is x square dx plus y square is x power 4 and dy is 2x dx. So it is from 0 to 1 x square plus 2 x power 5 dx, and this will give us answer because limits are 0 to 1 over 3 plus 1 over 6, again 1 over 3. Yani it will be 2x power 6 over 6. Over 6, 2 over 6, 1 over 3, and x is 1. So the final answer is 2 over 3. Very easy, straightforward, simple question. Find the volume cut from the sphere radius r equal to a by the cone alpha, theta equal to alpha. Calculate the volume when theta is pi over 4, when theta is, yani alpha is pi over 2. Okay, so let me show you how to do this question. Okay, the solution for this question is find volume, and this volume is in spherical coordinates. So we have to find volume. Volume mean triple integral. Integrand is 1. Then volume element in spherical coordinates. volume element in spherical coordinates is given in your formula sheet. Volume, that is r square sine of theta dr d theta d phi. Okay. Volume cut from the sphere, radius a. So radius is r is from 0 to a. Radius is from the center to the surface. R equal to a is the radius. So r is going from 0 to a, and theta is cut by the cone, theta equal to alpha, and first part is alpha equal to pi over 3. And you know theta is between z-axis, positive z-axis to the angle. So from 0 to pi over 3, it is a cone, and phi is not given here. In spherical coordinates, phi is all around 0 to 2 pi. So these are the limits. Now we integrate with respect to r. Limits are constant. We can separate these. So r power 3 over 3 from 0 to a. Multiply. Sine theta integral is minus cosine theta, and limit for theta is from 0 to pi over 3. Then it is phi from 0 to 2 pi for the phi. So it is a power 3 over 3 multiply cosine pi over 3 is 1 over 2 minus this minus plus cosine 0 is 1, then 2 pi. So inside is half, half and 2 will cancel. So it is pi a cube over 3. This is the answer. If anyone has any question, not clear anything, he ask me. If something is not clear, you ask me, Shabab. Okay. If you remember, I mentioned it before that f dot dl or vector dot dl is the work done by the force, and as you can see here that it is written the word in question number 3.7, if the integral is regarded as work done in moving a particle from point A to point B, then you need to find this work. And here are two parts. In part 1, we have two paths from 0, 0, 0 to 0, 1, 0, and then from 2, 1, 0 to 2, 1, 3. And in the second, we have just 1, 0, 0, 0 up to 2, 1, 3. And similarly, question number 3.8 is similar to this. Okay. Now let me show you this one. Which part you want me to solve for you, A or B?
B. A.
A. Both are A. Shabab, just tell me, don't write message. A. F dot dl. In A, when a point goes from 0, 0, 0, x is from between, so x is fixed, 0. So A, and let me say L1. X is fixed, 0, and we can say 0 less equal to y less equal to 1, and z is 0. So this integral from A to B, F dot dl, F is a vector, so this dl should be a vector. Now, when we take F dot dl, then since x is 0, so dx is 0. Dx is 0. So let me write here, dl will be equal to y ay hat, because dx is 0, dz is 0. So yeah, it will be L is y and dl is dy. So only y left, and y is from 0 to 1. And when we take dot product of this f and dl, f is given here, we get x square minus z square and dy. Ay with ay is 1, so dy. But z equal to 0, z is gone. X is also 0, x is also gone. So the whole answer is 0. Now line L2. L2 mean 2, 1, 0. So here x is equal to 2 fixed, y is equal to 1 is also fixed, and 0 less equal to z less equal to 3. So in this case, dl will be, since x is 2, so dx is 0, y is 1, so dy is 0, so only dz az, this will left. So the integral from point A to point B, f dot dl, this will be 0 to 3, only z part is there. And when we take dot product of f and dl, we get negative 3x z square and dz. Now x is equal to 2, so negative 6 is outside. Then z power 2, so it is z power 3 over 3 from 0 to 3. Okay, 0 to 3. Now when we put 3, 3 power 3 is 9, 27. 27 over 3 is 9. 9 times 6 is 54. So negative 54 is the answer. Negative 54 is the answer. Look at it and tell me if some step is not clear.
Doctor,
Yes?
for the step when you write minus 3x z square, what happened to the remain parts for f from f?
I cannot hear you loud, so come close to mic and yes.
Do you hear me now, Doctor?
Now I can hear you.
What happened to the remain parts from the f vector? I just say the last part. Doctor?
Close your mic. It's even worse. Mute your mic.
Did you hear me now, Doctor?
Yeah, that's it. Now
What
here
happened?
in L1, what y equal to 1, f dot dl is x0, z0. Okay. From this point to this point, yeah, there is one more left here. Let me try to insert space and insert space. Yeah, actually this should be L3, L2. L2 is from, let me do it in underline in a red color. L2 is actually, we didn't do this part here. I underline this. So it is from one point to the next point, and then here for L2 point 010 to 210. X is changing. So X is 0 to 2. 0 less equal to X less equal to 2. And then Y is 1 to 1. So Y is equal to 1. And Z is from 0 to 0. So Z is 0. Actually, let me write here dl. L is actually the vector L. What is vector L? X dx plus Y dy. No, sorry. Vector L is X component AX plus Y AY plus Z AZ. This is vector L from 0 to from 010 to 210 L. Now here X is a 2. So X is fixed 2. Y is X is no variable. Sorry. X is variable. Y is 1 and Z is 0. Now Z part is already gone. When Y is 1, we take derivative. When we take dl, then 1 becomes 0. So this is also gone. And first one become X. So dl for this part, dl is dx and ax. Now we take the dot product of in evaluating a to b, f dot dl. When we take f dot dl, what left? dl has only dxax. So this dx is multiplied by the first component, which is 2xy and dx. So this is the dot product. And here y is 1 and x is variable from 0 to 2. Y is 1, so it is x square from 0 to 2. This is equal to 4. So the overall answer from integral from a to b, f dot dl it is 0 plus 4 minus 54. So it is negative 50. Okay. I hope this is clear. If not, tell me, Shibab. Shabab, anyone has a question?
So, doctor, from the f vector, we just take the path which change. That change.
No, you take the dot product of f with L, with dl. Take dot product of f with dl.
Okay, okay.
And since in dl, in first dl has only a y component. So in the vector f, a y component will come in the integral. In L2, only dx with ax. So we have dx with the dl and 2xy with f. So they will multiply, and then we will take dot product of ax with ax. And dot product of ax with ax is 1. Mazboot?
Mazboot.
Okay, very good. 10:10. We have 10 more minutes. Now, here are many more questions. I don't know how many should I solve for you. Next question number 3.8 is along this figure. Now, if you look this figure, in this figure, the point is going from 1 to 0. So here, what are the coordinates of the starting point? There are three curves here. 1 to 0, 0 to 1, and then 1 to 2. Now, you can write the coordinates of these points. Coordinate of this point here, where is my cursor, is 1 comma 0 comma 0, and then it is going to 0 comma 0 comma 0. Then from 0 comma 0 comma 0, it is going from 0 comma 0 comma 1. Then from 0 comma 1 comma 1, sorry, 0 comma 0 comma 1, it is going to 0 comma 2 comma 0. So here three curves are given for question number 3.8. Very similar to 3.7. Now 3.9 is what? V is given here, and evaluate this VDS, where S is the surface of the cylindrical wedge defined by phi 0 to pi over 2 and Z between 0 to 2. Z is from 0 to 2, phi is from 0 to pi over 2. Okay. We need to evaluate this surface integral. We need to evaluate the surface integral. And limit for phi is 0 to pi over 2. Z is from 0 to 2. Okay. Now here question is, what is this solid? What is this wedge? If you have, for example, if you have a pipe, a cylinder, circular pipe, you cut that pipe into 4 pieces, then what surface we have here is one of the piece in which angle phi is going from 0 to pi over 2. So it is in the first octant, and the height of this cylinder is from 0 to 2, and it is not given how much is radius, yani rho, for this cylinder. What is the radius? Rho. Rho yani x square plus y square. This is V. Okay. Let us see how can we solve this question. What is this is 3.9, where S is the wedge defined by 0, and ds is normal to the surface. So the surface element for the spherical coordinates. Here, how much is the radius of this cylinder? It is not given here. Why? How much is radius of this cylinder? It is not given here. This is cylindrical wedge. Okay, fine. This cylindrical wedge will have a different surface area if radius is different. So what is the radius here? I don't know. What is the radius here? It is not given. So let us leave this question, because here maybe there is something we don't see in this question, or there is some mistake anyway. 310. A is equal to this. Evaluate A dV over this rectangular region. this cylindrical region, this spherical region. We need to evaluate 0 to 2, 0 to 2, and 0 to 2. Okay. So how do we do this? Evaluate A dV. dV, volume element, it is given to you. Okay. Now, how to do this one? We have how many different faces in this rectangular box, rectangular region? And we have a vector here. Vector, integrate this vector over dV. Vector over dV. How to integrate this vector over dV?
This cube, doctor.
We have 2xy and xz, and then we have a dV. This is vector A, and we have a volume element dV. What this question is? Vector A and volume dV is vector A and volume dV. A dV. Where do we have this one? dV is for the volume, and that is a scalar quantity. 2xy ax plus xz ay minus yaz. Still, it is not clear to me that what is this. So you cross 3, 9, 3, 10. The acceleration of a particle is given by this vector. If the position of particle is 0, 0, 0, so vector quantity, find the gradient. So 3, 9, 3, 10, and 3, 11, you can simply ignore them. These three questions, you can write it somewhere. So let me write here in red color. I'll try to find what is this, something is hidden in these questions. 3.12, find the gradient of these scalar, gradient. Simply use the gradient formula and then get the answer. Determine the gradient of the following fields. I think we did some question like this. So you can do this simply taking partial derivative. Determine a unit vector normal to this one. So this is application of the gradient. Let me do this. This is question number 3.14. And what they say here, determine the unit vector. Now, Shabab, you need to remember that if we have a surface, then gradient of the surface, remember gradient of S, which is also written as del S, which is partial S over partial x, then ax plus partial s. This is how we will find gradient in the previous two questions. Ay plus partial s over partial z, az. Derivative with respect to x, 2x ax plus derivative with respect to y, 2y ay, derivative with respect to z, -1 and az. So this del s at 1, 3, 0 is 2ax plus 6ay minus az, 1az. There is no z, so we are not putting z equal to 0. Now, what is the magnitude of this? What is the magnitude of this? It is 4 plus 36 plus 1. So this is equal to 41 square root. So the unit vector, they are saying unit vector, unit normal is equal to 1 over 41 square root, and inside is 2ax plus 6ay minus az. So this is the unit normal, 314. Okay, Shabab. I have done many questions. There are many more questions. You try to solve them. If you cannot solve any question, you let me know. Okay, and we will do that